Today is the second of the webinar in the scalability series. So this series of webinar talks about various scalability options in blockchain. So in the first webinar, we discussed about all the different options that are out there, which have been used, some as part of the early evolution, and then and rest of them are coexisting. So just to recap, we discussed about some of the Bitcoin, like Bitcoin Lightning, Layer 2, etc. We also discussed about side chains. We discussed about rollups, optimistic rollup and ZK rollups. We discussed about plasma, and then we also discussed about app chains, the new concept where some of the large protocol ecosystems like Polygon or Avalanche, they have launched the concept of app chains where you can create your own custom blockchain, still get the security and decentralization from the main chain. So out of all different scalability solutions that we discussed, today we are talking about specifically focusing on rollups. And in the third of the and final part of the webinar, we'll be talking about app chains. So let's get started with rollups. This webinar is a bit more tech intensive, but I'll try to make it very simple. Won't go into the details of the tech part of it. But yeah, some slides will talk about how the technology architecture, how the process, etc. works. So first, generally understanding what rollups are. So rollups, like any sidechain concept, is that what is the scalability conundrum or scalability blockchain trilemma issue that people have talked about. Just a brief recap on that. So there are three sides to a blockchain network. There is scalability, there is security, and then there's decentralization. So these are three focus areas for a proper network, which we call decentralized network, a censorship resistance network, but at the same time provide very good user experience to different users, right? Because end of the day, users are going to run applications, users are going to use applications over blockchain. So we want the user experience to be good. For that, blockchain does require scalability, which is draws parallel to the scalability that we have in the Web2 applications. But the challenge is that if you increase the scalability, now there are various options of increasing scalability. If you can package more transactions into a block, right? Or you can write the blocks faster. But if you do these things, the decentralization and security suffers. Why decentralization suffers? Because when you package more transactions into a block, you increase the size of the block, then the block will become more expensive. There will be less node providers who would be running the network. So it will impact the decentralization. If you, it may also mess up with the consensus, because once you start writing blocks in a much faster rate, of course, the whole idea is of the validation is that each block, sync up a copy of the ledger. So if you increase the throughput to a larger extent, it may impact that, not every node has been able to sync up before the new block is written. So these are some of the challenges. And what Ethereum decided, if you see the statement from Vitalik, Ethereum decided that they will, try to make Ethereum more decentralized and more secure. So they will focus on security and decentralization. And even if for that purpose scalability suffers, that's completely fine. We are talking about Ethereum main chain. But if you want to increase the ecosystem, if you want to see more adoption, of course, the scalability challenge needs to be solved. And that's where this whole concept of layer 2s came in. So layer 2s, generally what they do is, whenever the transactions are submitted on the Ethereum main chain, those transactions are validated, verified. There's a lot of computation which is get involved. And then those transactions are submitted It involves a lot of gas fee also. And as more and more users start using Ethereum network, the gas fee keep on increasing. There's more congestion because there's a limit to the resources that can be utilized for every block. So these layer 2s, what they do is they take away this computation headache. They batch all the transactions off chain within a layer 2, within a separate blockchain, and then submit the final proof to the main chain. So that way they are taking away the computation part of it, the transaction load part of it, the size of the transaction, etc., thereby increasing the efficiency as well as in terms of throughput, as well as reducing the gas fee. Because now there's not that kind of competition where people are bidding for the gas fee. So this is the core purpose of layer 2s. And rollups are prominent when we talk about the layer 2s. Why they are called rollups? Because you take a batch of transaction and they are bundled or rolled up into a single proof, which is submitted on the main chain. That's why they are called rollups. And as I mentioned, the whole idea is to reduce gas fee, increase the transaction throughput, because you're offloading the computation and storage from the main chain. So how Ethereum rollups aid scalability? So if you see, like, in the bottom, there's a rollup. So all the transactions are happening at the rollup stage. They are verified, then packaged into a single block. And then there are a set of smart contracts on the main chain where, for example, layer 2s on Ethereum, they use the call data, where they bundle all the data into the call data and store that on Ethereum. So it does not impact, you're not using the transaction space or memory to store this data. So that's why we are reducing the load also from the main chain and at the same time increasing throughput. So there are two kind of prominent type of Ethereum rollups today. One are called optimistic rollups, and the second are called validity rollups or ZK rollups. So ZK here refers to zero knowledge. We'll come to that later. So these are primarily two, and we'll talk about different players using different. So let's first start with optimistic rollups. So optimistic rollups, basically why they're called optimistic, because in both optimistic and ZK rollup, end of the day, you are doing transactions off chain and then submitting the proof on the on the blockchain. But in the case of optimistic rollup, what happens is that the validation of each transaction does not happen on the layer 2. So it is assumed, the optimistic rollup, they assume, they are optimistic that whatever transactions are being submitted are valid. And it passes the owners to a third person who can verify, validate those transactions. And if any transaction is found to be invalid, it will be reversed. So talking it simply, what they do is they package the transactions, they submit the transactions, assuming that the transactions are valid, the final state that they have submitted, that is valid, and then they open a window, a time frame. For example, let's say in the case of Optimism, 1 week, and within 1 week, there can be a challenger who can check all the transactions, and if they find a transaction which is considered to be fraud or invalid, then they can submit those transactions. And there's a mechanism of how incentive structure works, because people who are submitting these fraud proofs, and if their fraud proofs are found to be right, then they are incentivized to do it. And the other person who submitted these proofs in the first place, they are penalized. So this is the process, and that's why they are called optimistic rollups. Now the challenge with this process is that now, since optimistic rollups are not doing all the validation on this side chain or on the layer 2, so that's why they are faster. But at the same time, the finality has an issue, because just imagine you have done a transaction, the state has been updated on the blockchain, but there's a challenge period of 7 days. So if you want to withdraw funds, you would not be able to withdraw funds for these 7 days. So since the finality it takes a longer period of time, that is one big challenge with optimistic rollup, based on the process that I just outlined. But yes, they offer increased throughput, they offer reduced gas fee, and they are much faster. So these are largely the 5 steps in optimistic rollup. So users submit transactions, there's an off-chain validation, then there's a block aggregation that happens. You bundle all the transactions into a block, which is a rollup block happening on the layer 2. And then this is submitted then on the Ethereum mainnet. So the block, includes a single transaction that will update the state of the Ethereum contract. And then, there is a period where any dispute can be raised about the validity of a transaction, and the fraud proof can be challenged. And if there is no challenge, then of course it becomes final. But if there's a challenge, then it leads to a reverse. Everything, all the transactions in that block and subsequent blocks are reversed, and then proper transactions are resubmitted. So this is how like from a architecture standpoint, optimistic rollups are managed using there are set of smart contracts, which are deployed on Ethereum, and they store the rollup blocks and track the state. And then there is the optimistic virtual machine, which basically does all the stores off-chain state and performs computation on the layer 2 as part of the optimistic rollups. And as I mentioned, there's a process of fraud proof and challenging. Now, fraud proof has got a very interesting incentive mechanism. So one, anyone who is submitting the proofs, they are putting in a bond, like what happens in proof of stake, where you're putting in a stake and you're validating all the transactions. And if you do any kind of misbehavior, your stake amount that you have put in can be slashed. So similarly, in this case, somebody who submits an invalid transaction, and then they are later caught by someone, a challenger, let's say, submits a fraud proof and says that some of the transactions are invalid. So the person who validated that block of transactions will be penalized. So slashing will happen. So they need to put a bond in Ether, and the fund would be slashed. Similarly, if let's say the challenger who is submitting the fraud proof, if he submits a wrong proof, then they also need to put in a bond. And so if whatever invalid transactions they have reported and it is found that those transactions are invalid, then the challenger would be rewarded. But if it's the other way around, they are not found, so then it's like wasting each other's time on the network and delaying the finality of the transactions on the network. So then the challenger would also be penalized by slashing. So it works both ways. And this way, it ensures that there's enough incentive mechanism set here. So these kind of proofs work. So optimistic rollups, work properly. Some of the most popular optimistic rollups, one is Optimism, second is Arbitrum, and then there are a few now, a lot of other optimistic rollup are coming in, because now optimistic rollup code has been put on open source. So anybody wants to build on their own custom blockchain using optimistic rollups can do so. And so these are the two major players, Optimism and Arbitrum. Optimism, there's a native token which is OP. In the case of Arbitrum, there's no native token. And Arbitrum has done some, modifications to the plain vanilla optimistic rollup. Optimism is fairly plain vanilla optimistic rollup, as we have discussed. So there's a single round fraud proofs, which are submitted on the layer 1, and the layer 1 execute that, and the layer 2 transactions are happening off chain. And then the layer 2 transaction gas is also bound by the layer 1 block gas limit. This is again one challenge of optimistic rollups, that sometimes you cannot increase the weight of the block to a level, because there's a restriction on the gas that can be utilized by the smart contract. And they leverages Ethereum Virtual Machine, and it leverages pure optimistic rollup technology. Vis-a-vis that, if you see Arbitrum has done some modification. They have its own Arbitrum Virtual Machine, and the layer 1 block gas limit does not matter much on the layer 2 transactions, because they are never entirely executed on the layer 1. And they also use a unique rollup design called Validium, which combines optimistic rollup and zero knowledge proof system also. That will come in later. So this was about optimistic rollups. Now let's talk about ZK rollups. So ZK rollups are also called validity rollups or zero knowledge proof rollups, ZK rollups. So what is zero knowledge proof? Zero knowledge proof basically allow one party to prove to the another party that a statement is true without revealing any underlying information. So you submit the validity of a statement or a data without divulging the actual data or the actual information which is underlying. So those are called zero knowledge proof. It's a mathematical concept and completely based on maths. So zero knowledge proof, became very popular in the blockchain space in last 2-3 years. A lot of privacy related platforms have come up. Some privacy related blockchains also came in which were using zero knowledge proof to enhance privacy of transactions, right? Now zero knowledge proof blockchains are coming in. So these are ZK rollups, which are basically what they are doing is, again, as a rollup, the process is same, that you are bundling all the transactions, you are creating a batch of transactions on an off chain, on a side on a side chain, and then you are putting those transactions on the chain. So the difference with ZK rollups as compared to optimistic rollup is that they offer faster transaction finality, because in the case of ZK rollups, unlike optimistic rollups, all the validation happens on the layer 2 itself, on the rollup chain itself. And once they have been validated, then they are submitted. The proof of that validity proof is submitted on the mainnet, the Ethereum mainnet. And then they verify, there's a verifier contract on the mainnet. And the proof is structured in such a way that the verifier can easily verify that it is completely valid set of transactions. And that is the reason there is no waiting period, there is no withdrawal period that happens in the case of ZK rollups. So it has got a much faster transaction finality. And of course, as a layer 2, it offers high throughput and low gas speed. But yeah, ZK rollups are quite expensive in terms of complexity of understanding, etc. And in fact, when the whole concept of ZK rollups started coming in, it was said that it may take many years before this can become a reality. But in last 1.5 years, there has been a race for ZK rollups, and the amount of innovation that has happened in this space, we are already seeing a lot of mainnets being in the market for ZK rollups. One of the other difference, in terms of efficiency is that ZK rollups use account indices. So account indices are smaller in size as compared to the Ethereum account. So Ethereum account, let's say, is 20 byte in size. The ZK rollup account indices are just 3 byte in size. So that also, reduces load on the memory and increases the efficiency. They occupy less space also. So this is the anatomy of ZK rollups. Basically, there is a set of user transactions. Transactions are batched, and then a snark or a Stark proof, which is a cryptographic proof using zero knowledge proofs. So those validity proofs are then submitted on the mainnet. And since these proofs are already validated, there is no challenger concept here, and one just needs to verify. So if you see, this is how the different components work. So user initiate transactions on the rollup, and then there is a sequencer which basically receive and aggregate all the individual transactions and create a batch, and then put them into a specific order. And then prover plays a very important role in the case of ZK rollups. So prover is something which is using all the cryptographic tools like ZK Snark or ZK Starks to generate zero knowledge proofs, which are like validity proofs, which ensures that all the transactions that are being submitted are completely valid. And then prover submits these validity proofs on the main chain on the layer 1. And on the layer 1, there's a verifier smart contract, which basically checks the validity of ZK proofs. And the ZK proof are designed in such a way that it can be quickly verified. So And then there is a rollup light client on layer 2, which receives the updated state information. So as soon as the verifier verifies it, the state is updated on the layer 1, and the layer 2 also get a notification that the state has been updated. So the popular blockchains which are using ZK Rollups are, one is Polygon, then Starknet, ZK Sync, and then Scroll and Aztec. So these are, in fact, Starknet, ZK Sync, and Polygon are quite prominent players who are working on the ZK piece. What are the limitations of ZK Rollups? So the major limitation of ZK Rollups has been there's a limited EVM compatibility functionality. Now, in the case of Optimism, it is EVM compatible, so you can migrate all the tools, all the smart contracts without changing any base logic and use them on optimistic rollup chains. But that is not true for ZK Rollups. So they have very limited EVM compatibility, and that leads to a learning curve, and none of the existing smart contracts can be easily migrated to them. Because the way the calculations are performed in the case of ZK Rollup is different. That's why this limitation comes in. But now in the next section, we'll talk about how this limitation has been removed to a larger extent now by combining ZK Rollups with EVM. But by default, ZK Rollups, they have a very limited EVM compatibility. So to sum up the comparison between optimistic rollup and ZK Rollups. So in optimistic rollup, there's an economic crypto incentive. As I mentioned, the transactions are batched, they are submitted on layer 1. And then there's a challenger period who can, challenge the fraud proofs. And there are economic incentives to do that. So based on that, the validation happens. In the case of ZK Rollups, it is mathematically done. As we mentioned, the prover node, the prover actually runs the cryptographic computation using ZK zero knowledge proofs, and use that for validation. Invalid transaction, if there is an invalid transaction, then it can be challenged by running and submitting a fraud proof, and the person who is submitting the fraud proof is incentivized to do that. In the case of ZK Rollup, that is not required, because all the validity is happening on the layer 2 itself, and it's only after it has been validated it is submitted on the layer 1. And there's a latency or a withdrawal period, like it may be 7 days, a bit less, but there's always a period when any dispute can be raised, any fraud proof can be submitted. In the case of validity, it is immediately after the proof and state is updated and it is verified on the chain. There's no other period. The other difference, in the case of optimistic rollup, the data stored on chain is a full transaction data, but it is bundled into a batch and submitted as a call data, but it's full transaction data. In the case of ZK Rollup, as I mentioned, the whole concept of ZK Rollup is not to divulge the full information, but just the proofs of it. So only the necessary data, bottom line balances, for example, they are updated and the state is updated. EVM compatibility, optimistic rollers are compatible. Validity, ZK Rollups by default are not compatible or very limited EVM compatibility. But now in the next section, we'll talk about ZK AVM rollups. So what are ZK AVM rollups? So the idea is that, how to remove the limitation of ZK rollups as far as EVM compatibility is concerned. And today we have seen that, any new blockchain which comes in with their own programming language, own set of tools, the adoption suffers big time. It requires huge amount of efforts on the protocol side to actually find developers who can start building on these chain and users willing to learn these new tools. So the easier way, of course, is Ethereum has got one of the largest ecosystem. There are lots of developers who are experts on building or writing contracts using Solidity, etc. And then there are a plethora of ecosystem tools, whether it be wallet infrastructure, whether it be a blockchain infrastructure as a service, So all kind of ecosystem pieces are there on Ethereum. So if ZK Rollup, which is a very exciting technology, we have seen, how it improves the throughput, has got a solid finality. If it gets a compatibility with EVM, then it becomes a game changer. And that is what ZK AVM are. So if you see in this case, again, the process pretty much remains the same. But now this ZK Rollup is EVM compatible also. So so if you take an example, Polygon ZK AVM, which launched their mainnet beta in March 2023, one of the most exciting projects. We are partners with Polygon ZK AVM, working very closely with Polygon team on providing infrastructure automation on Polygon ZK AVM node infrastructure. So and I'll come to the types. So there are various types of EVM compatibility and various features. So right now, Polygon ZK AVM is a Type 3 ZK AVM. And another interesting thing about Polygon ZK AVM is it uses the unique proof of efficiency consensus mechanism in conjunction with a cluster of state machines. And in terms of data availability, it uses Validium, as we discussed about Validium for Arbitrum. So in this case, validity proofs are stored on chain, while some data is stored or on or off chain. And as I mentioned, mainnet beta is already live, and it already has got TVL of 30 to 40 million. I checked in the morning, it was 28 million, but yeah, it has reached 40 million in the past. So we are seeing already, it's only 2 to 3 months, when Polygon launched ZK AVM. And today, in fact, there was an announcement by Polygon Labs where they are combining Polygon POS and Polygon ZK AVM. So we are going to see the usage of ZK AVM more and more from Polygon. These are different kinds of ZK AVM based on performance and compatibility. So compatibility is based on how compatible they are with Ethereum. So more compatibility means that the environment is exactly like Ethereum, where you do not. So if you are running a decentralized app, you have your own set of smart contracts. They can be ported as it is. So that is more compatibility. Lesser compatibility means that there would be some challenges. Some limitations still remain. And then, but on the performance side, if you see, so compatibility wise, it moves from 4 to 1, and on performance side, like if you see the ZK AVM Type 1, they are highly compatible, but they take a very long time to generate proofs. Vis-a-vis that, if you see Type 4, they have the fastest proof generation time. They save cost and reduce centralization risk, but there needs to be some changes. It needs to be either recompiled or some changes need to be done. So this is how it's happening. And so of course the focus is to bring in a balance, like Polygon ZK AVM is Type 3, which they are faster to generate proofs, but at the same time they have a decent compatibility with Ethereum. And now they are moving on to Type 2 in terms of compatibility. So that is the next roadmap item for Polygon ZK AVM. The future ahead, of course, ZK AVM is a new thing, but that removes all the limitations of ZK Rollups, which is a very exciting technology in terms of scalability. And now, in fact, blockchains can talk about using sharding as one mechanism, where we see Shardium or Near protocol. But if you talk about ZK Rollups, they are one of the most exciting technology for layer 2s of a scalability solution. And ZK AVM, of course, makes it even better, because now we have Ethereum compatibility, EVM, Ethereum Virtual Machine compatibility. So makes it easy for somebody to adopt the newer chains. As a note, Zeeve is blockchain infrastructure as a service platform. We provide node infrastructure, we provide network infrastructure. If somebody wants to set up their own blockchain or use the existing blockchains by deploying a node or using the RPC endpoints, Zeeve provides a complete set of blockchain infrastructure as a service. It's a no-code platform offered as a SaaS platform. So, and then, for all the popular rollups that we talked about, whether it be Optimism, Arbitrum, Polygon, ZK AVM, Starknet, we support all different protocols. And some of the interesting pieces we are doing is on the app chain, which I'll discuss in the next webinar. We have partnered with Polygon Labs to provide full support for Polygon ZK AVM supernets also. So the whole supernet can be deployed and up and running in just few minutes. Normally doing it manually may take 3 to 4 weeks, but a complete network along with all the necessary components, whether it be Explorer, wallet infrastructure, cross-chain bridges, everything is set up in a no-code automated manner. We have on the platform, we have 26,000 plus developers, 30 plus large enterprises who are using the platform for various protocols. So if you're building a dApp and you need blockchain infrastructure, whether it be node infrastructure, RPC endpoints, or you are planning to launch your own custom blockchain using rollups or different app chains, you can always connect with us, and we'll be very glad to help you with that. So do connect us on LinkedIn, Twitter, Telegram, or Discord, and you can connect with our technical team. You can connect with our sales team. If you have any questions, you can connect with me on LinkedIn, and I'll be more than happy to answer any query or questions or any clarification. Keep building, keep smiling. Thank you. Thanks, everyone.